Welcome to Daily Papers, the podcast where we break down fascinating new research papers so you don't have to. Today, we're looking at a challenge for AI that you might not have thought about: drawing.
Now, I know what you're thinking. AI is already amazing at drawing. You can ask an AI to draw an astronaut riding a horse in space in the style of Van Gogh, and it will give you a masterpiece. But what if you ask it to draw a simple geometry problem from a high school textbook?
That's the question at the heart of a new paper called Math Vision Diagrams, a benchmark for evaluating LLM mathematical diagram generation capabilities. It turns out that asking an AI to draw a precise diagram is a completely different and much harder ballgame.
Exactly. If you ask for a cat and the AI draws a cat with slightly longer whiskers or a different patch of fur, it's still a cat. It's visually plausible. But if you ask it to draw a right-angled triangle with specific side lengths and the angle is 89 degrees instead of 90, the entire diagram is mathematically wrong. It's useless.
A single misplaced label, an incorrect angle, or a wobbly line can render a math diagram completely misleading. This is a huge problem if you want to use AI for things like creating educational materials, illustrating scientific papers, or in engineering. You need precision.
But here's the catch. Most of the tests we have for these big AI models, or LLMs, are about understanding diagrams, not creating them. So the researchers in this paper decided to build a brand new test from the ground up.
They call it the Math Vision Diagrams Benchmark, and it's a serious test. They started with over 3,000 high-quality math problems from competitions, the kind with diagrams that are essential to solving the problem. Then they developed a really clever pipeline to create a perfect text description for each diagram.
This is my favorite part. To make the text prompts, they first used several different AI models to describe the image. Then they used another judge AI to look at all those descriptions and the original image to create one final super clear prompt. And to top it off, they had human subject matter experts, people with graduate-level math backgrounds, check the prompts to make sure they were good enough for a person to draw the diagram perfectly.
So now they have a gold standard data set, a perfect text prompt, and the perfect image it's supposed to create. The stage is set for an AI showdown. They tested 11 different models, which fell into two main categories.
The first category is text-to-code models. Instead of drawing the picture directly, these AIs write computer code that describes the diagram, things like SVG or TIX code. It's like giving an architect a detailed blueprint. That code is then compiled to create the final image.
The second category is the one we're more familiar with: text-to-image models. These are your DALL-Es and Midjourneys. You give them the prompt and they generate the image directly. This is more like describing a scene to an artist and having them paint it.
So, with all these AI models trying to draw these diagrams, how did the researchers grade them? They couldn't just eyeball it. They used a suite of smart evaluation metrics.
First, for the text-to-code models, there's a simple first check. Did the code even work? Did it compile and produce an image? That's the compile rate.
You'd be surprised how often it doesn't.
Then, for all the images, they used two types of metrics. The first were perceptual metrics, which basically ask, does the AI's drawing look like the correct one? They use a metric called clip similarity, which measures if the concepts in the two images are the same.
But looking right isn't enough in math, so they also used structural metrics. These metrics analyze the edges and lines in the diagram to see if the geometry itself is accurate. They ask, are the lines and shapes in the exact right places? This is where precision is really tested.
All right, so let's get to the results. Who won the AI Diagram Olympics? Well, it's complicated. There was no single champion.
One model, Claude Opus 4.6, was the best at creating diagrams that looked good and made sense perceptually. It was the best artist.
Another model, Gemini 3.1 Pro, was the king of structural precision. When it worked, its diagrams were the most geometrically accurate. It was the best architect. But, and this is a big but, its code failed to compile almost 30% of the time. So, a brilliant architect who only shows up to work 2/3 of the time.
And what about the text-to-image models, the pure artists? The researchers tested models called Nano Banana Pro and Nano Banana 2. They were the most reliable. They almost always produced an image. But their drawings lacked the sharp geometric precision of the best code-based models.
This points to one of the biggest takeaways. The architect approach, generating code, seems better for math. Even though it's less reliable right now, that intermediate step of creating a structured, logical blueprint leads to more precise drawings, which is what matters most.
The researchers also found that not all math is created equal. The AIs were pretty decent at standard high school geometry, your basic circles, triangles, and polygons, but they really struggled with more complex tasks.
Yeah, things like statistical charts, which require precise placement of data points and labels, were a big challenge. And they were completely stumped by things like topological diagrams, think complex knots in surfaces, and transformation diagrams that involve rotations and reflections.
And there was one more surprising result. One of the most advanced models they tested, which they refer to as GPT 5.4, was consistently the worst performer. The researchers have a theory here. They think the model's advanced chain of thought reasoning, which is great for solving complex problems, might actually get in the way here. It overcomplicates things, writing complex code that ends up being buggy and producing an incorrect diagram. It was literally thinking too hard.
So what's the big picture here? Why does all this matter? It's because if we want AI to be a true partner in science, technology, engineering, and math, in STEM, it has to get the visuals right. Imagine an AI tutor that could generate infinite practice problems with perfect diagrams for a student, or a tool that could automatically create figures for a scientific paper.
This benchmark, Math Vision Diagrams, is a huge step in that direction. It provides a standardized way to measure progress and highlights exactly where today's models are falling short. It shows that while AI has become an incredible artist for creating beautiful, plausible images, it still has a long way to go to become a reliable mathematician.
It's a great reminder that in the world of AI, as in mathematics, precision is everything. Thanks for tuning in to Daily Papers.